Good afternoon, it's Jeremy. It's Sunday, October the 12th, and this afternoon I'm receiving GOES16. I received it a couple of years ago. There's my dish, and I got a new balcony now, so it's not quite as sturdy as the old one. The old one had flat steel beams. Now we've got these kind of aluminum things. Anyways, this is just a temporary mount. I'm going to take it down in 5 minutes. So we can see our signal here. It's about between 5 and 8 dB above the noise level. I'm going to try and decode it with SatDump. Previously, in the previous video, I used SatDump to decode Meteor, so it's a really interesting program. A couple of years ago, I decoded the signal on Raspberry Pi, so we're going to see what happens now on Windows with SatDump.
Okay, so here's a look at one of the signals that I received yesterday. I received about 3 or 4 signals yesterday, and then I went back and did some more this morning. So here's one of them, and you can see we're in L-band here at 1.694.1 megahertz. And I was sampling, when I recorded this signal, I used the baseband file recorder. I was sampling at 2.4 megasamples per second. And I adjusted the gain between, I started off at 42 dB, but I noticed at 29 dB I got more gain actually because the intermod came up. So between the noise level here and the peak of the signal, it's anywhere from, let's say, 5 to 7 dB. So let's look at SatDump. So here's SatDump. So what you have to do is you open the file that you've saved, your baseband IQ file. I put them all in the SatDump directory. I take them out of the SDR Sharp IQ directory, put them in SatDump. Create an output folder that matches a particular file. Okay, so you have to set those two up. And then you got GOES HRIT, and then we start, and we can see what's going on here. You can see the BPSK dots there. There's a fair amount of noise. And between the various signal captures I did, these are some of the images I received. Here's a surface temperature map. There was some noise in there and blanked out. There's mid-level tropospheric water vapor. There's long-wave infrared, and then you got all these National Weather Service maps, which are really interesting. So just with a few signal captures, you can get a lot of information.